So first of all, in terms of host overhead, we can think about for a minute. There's been significant research and development effort for many years to mitigate overhead. So when you take networking, you learn about the layers of a network system, the network layer, the data link layer, the physical layer, the transport layer, and even early operating systems work. Software design really, basically, in many cases, focuses on the right abstractions between various layers. And this is, it's good design, it's necessary. A layer needs to be simple, with tractable, understandable bit of functionality so that developers can understand what's going on, and then we can compose these layers together for additional capabilities. So that's good, but layering has performance impact, a significant performance impact in many places. So early effort in networking observed how much overhead there is in taking something from the transport layer to the network layer to the data link layer, and chunking and segmenting a bit of data, adding headers in an onion-like fashion around that data to send over the network is good again, but if you are not careful, it certainly can destroy the performance. So one key idea there, probably the key idea, is data copying. If a given packet that's being prepared needs to be copied from one place for network layer processing to another place for data link layer processing, then the overhead of that is significant. It's difficult to maintain high bandwidth in that case. So early work focused on ways that a given packet could be handed off rather than copied, and the onion layers of headers could be added without ever having to copy it from one place in memory to another place in memory. You think memory access on a local host is very fast, but when you consider the performance that it requires, that is required to maintain high bandwidth as network speeds continue to grow, then even those single copies begin to have an impact. So early work focused on eliminating those. Later work focused on the fact that when a network system call is invoked, when a write system call is invoked on a socket, for instance, you have to copy the data from the user memory, from user space to kernel space. Even if it's never copied again with the addition of the packet headers, it still has to be copied that one time. And again, you think system call overhead, little data copying among friends, what can be the problem? Yet that overhead can be significant. So another body of work is focused on what's called zero copy, which is the ability to take data directly from user space, send it to the network interface card without ever having it copied from one place to another. So as I said, this idea is zero copy. And there are advanced APIs to manage this network functionality. One instance that grew up in the InfiniBand technology, now called Open Fabrics, is what's called the Burbs Api. This is based on years of academic research and various other standards, UNet, VIA, for the last few years, that have given us this capability. So it's interesting. It's essential for high performance network applications, but it's potentially difficult to use. Just as an aside, you can think about part of the problem from copying directly from user space to the network device is that the network device needs to see through the virtual address to the physical address where the data lives in memory, and there are various interactions in the system that necessitate, the first thing that has to happen is to send a bit of data is it needs to be penned in memory, meaning you need to tell the paging subsystem this page is not eligible to be swapped out because we need to establish a physical to virtual address translation that needs to be fixed until the data actually makes it to the network interface card. So what in the normal world is simply invoking the write system call now becomes a multi-step process. You need to register the memory with the subsystem, pin it so that it doesn't get swapped out, and that the physical to virtual, the physical virtual address mapping is consistent for the duration of the pinning. then you invoke the transfer. But for purposes of performance, again, you don't want to invoke the transfer and wait for it to complete. You'd like to ideally invoke the transfer, go off and let the processor do other useful things, and then come back once the data has made it to the network interface card and gone across the network. So pin the memory, establish the transfer, go do useful things, then come back and wait for the transfer to complete or check the status of the transfer completion. So this is important in terms of performance, but it is not necessarily the easiest thing to use. And therefore, some of my work and the work of many, many others has focused on ways to make that usable, to embed that functionality in applications without embedding it in every programmer's lexicon. So stepping back from that, those are the techniques that we need to make the network go fast with low overhead. So now stepping back to think about virtualization. What happens in a virtual switch, in a software switch? The virtual machine bundles up, hopefully without copying, bundles up a bit of data, sends it to the virtual network interface device, which is really now just a bit of software that then copies it out of the virtual machine's address space into the virtual switch's address space, which then actually copies it out onto, if necessary, copies it to the physical network interface card. So years of work to eliminate copying, and virtualization, for all its good benefits, all its benefits now introduces another layer of copying. So the question is, there are various questions. How do we provide isolation of virtual machines without having this significant performance impact? And there are techniques to be able to bypass the virtualization for certain network streams that allow you to copy from virtual machines address space directly to the network interface card in certain cases. So that's a good thing. At the same time, that runs at cross purposes with the virtualization, the virtual network technologies that we talked about before. So this is a challenge and certainly an open issue, something that smart students need to be thinking about, experimenting with, doing research on, and there's a lot to be done there. It's an exciting space.